you need to mix a 20% acid solution with a 60% acid solution. And of course, I put this in here because most students hate the acid ones, because usually it's actually because of the percentage. Hopefully we'll see that it's not too bad. To create 200 milliliters of a 30% solution, how many milliliters of each solution must you use? All right, so we have the two parts, right? We got the 20% acid solution, then we got the 60% acid right there. So that's part of the mix, right? So I'm going to say I've got just to make the equations, we got the 20% acid, and then we got the 60% acid. Let's make that pretty. There we go. Okay. And then we have, I guess we have the solution as well, the final solution, which is the 30% solution. There we go. So we need to acknowledge that when we combine those two, then we should end up with a 30% solution. So, I mean, you could show if you added those together, you need some kind of 30% solution. Now, this is not the equation. This is how the equations are going to set up, though. Okay, so please don't get those confused. So we got 20% solution. You know what? I'm going to say that X is, I guess, milliliters of the 20% acid. And then the other value, the 60% solution, again, we don't know how much that is, so I'm going to use Y on this one. But again, that's milliliters of 60% acid. All right, so our first equation is going to be, I'm going to base this off of, I feel like I should do it on milliliters, but I'm going to do it on the percents, okay?
Wait, what?
I'm saying percent because I don't know the scientific term for what it is. Maybe it's the solution, percent solution. And I feel if I put that on there, I feel better in my heart, but I don't know if that helps you guys out. Percent, the first equation is just going to be based off the percent solution, okay? So how do you find the percent of the solution? And I guess it's kind of like, again, I'm trying to think of the word, and it just never works in my head. Maybe it's because I'm a math nerd, but if we take the amount of the 20% acid and just multiply it by 20% right here, that tells us kind of the final solution, just based off of how much we have. It's 20% solution and how much we have, so it's 20% solution. So yeah, what you're saying is if you wanted to use 20 right here, I do believe it works so long as all the percentages are written as whole values. Well, like I said, I'm using 0.2 because that's the decimal form of 20%. So yeah, is this the only way to do it? Of course not. And if you have your own way, yeah, feel free to do that. Do it that way, okay? So the 60% acid, we got to multiply it by how much acid that is, which is Y. And then it's concentration, I guess, 60%. But like I said, I'm going to write it as 0.60. So that's the 60% acid. And then we have the final solution, which is 30%. So that'd be 0.30.
You gotta stop saying final solution. You sound like a Nazi.
Oh boy. Okay,
It'll
so
make you better.
thank you.
Okay, I love the Jewish problem.
So there's 200 milliliters of that 30% solution. We just don't know how much of it is 20% acid and 60% acid, but we do know how much of the final solution we want. So we see that this equation sets up this way. Of course, if you were adding the two acids together, the 20% and 60%, we want the final solution to be at 30%, 200 milliliters at 30%. Now, for those of you science nerds that are like, I already know what that is, you know, with the percent times the amount, mathematically, we would say it's a percent milliliters, but again, that just doesn't make sense in my head. All right, and the next equation is based off of the milliliters. So the 20% acid, there's X milliliters, and the 60% acid is Y milliliters. If we were to add those together, we should get the final mix, which is 200 milliliters. And that is our system of equation. All right, so this top equation, 0.30 times 200. So I'm actually going to see what that is. 0.3 times 200, I think it's 60. There it is. Okay, so what I'm going to do is I'm going to set this aside just so we know where it came from. And in fact, I'll just kind of set it there. And then, but I now know that when I multiplied those two, that I got 60, right? So let's get rid of this, and let's replace it with the value that we get from the multiplication. Really, that's for me, just so I don't forget, but not everyone needs that right there. So now I have a value of 60 right there, okay? So this now, these two equations are able to be solved, right? And I'm looking at coefficients of x and y's, doesn't really matter. I just need to eliminate one of them. I'll choose the x's just because it's a smaller number, and really that's the only reason why I'm doing it. But do you have to eliminate the x's? No, you can eliminate the y's. So I'm going to take the bottom equation. The top equation, it can stay how it is. Okay, so that'd be 0.20x plus 0.60y, which equals 60. Okay, so that's the top equation. But we have the bottom equation. Let's go ahead and take it. And we're going to multiply the whole thing by 0.20. In fact, I'm going to make it a negative so that the coefficients will automatically be opposites. So here's what we get. Negative 0.20 times x would be negative 0.20x. And again, these are opposites. The coefficients are opposites right now, so I know they will eliminate, but also times the y. So that'd be negative 0.20y, which would equal 200 times 0.2 negative, which is negative 40. So from these two equations that we have, if I add them together, which I will do, and add all of the columns together, that will eliminate these x's. Okay, so I got 0.60y's plus negative 0.20y's, which is 0.40y's, which equals 60 plus negative 40 is 20. And then last of all here, just to solve that last part of the equation there, I just want this to be y equals, so I'm going to divide both sides by 0.40. So 20 divided by 0.40. My calculator gave me 50. Now again, what does y represent? Y is the milliliters of acid right there. So I'm just going to label that 50 milliliters. And that was of the 60% acid. I'll just be a little more specific on this one. 50 milliliters of 60% acid. Now that I know how many milliliters of 60% acid, and we also know that the total mix will be 200 milliliters, I just need to subtract those 50 milliliters, and that will tell me how many milliliters of the X, that's the 20% acid. 200 minus 50 is 150. Again, that's milliliters, but that's of the 20% acid. So let's just check. Okay, so 150 plus the 50, that's 200. That was easy math. But how about 0.2 times the x, that was 150, plus 0.6 times the y, which was 50. If I push enter, I get 60. And remember, we already multiplied the 30% times 200, so that's a 60 right there. It checks off. Both of those give us a true statement. And now I know that we have found the solutions.